All right, everybody. This is my second take of the distributive property to talk about things that are a little bit more difficult with the distributive property. So up here, I have 2x plus y. Remember, we can't add them together because they're not like terms. And what this is telling me, the 2, the coefficient 2, is um, is telling me that I have 2x's. The y there that doesn't have a number out in front of it, doesn't have that coefficient out in front of it, tells me that I have 1y, right? So here I've got 2x's and 1y. So if I went and put parentheses around it like this, that would be what I talked about in the other video. This would be putting it in a bag, right? So I still have 2x plus y. Now, or 2x's and 1y. So if I come out here and put a 4 in front of it, now what this is telling me is that I have 4 sets of 2x plus y, right? So if I have 4 sets of 2x plus y, I can write this guy out as 2x plus y 4 times plus 2x plus y, 2x plus y, and I'll come back over here for my fourth one so I don't run out of space. 2x plus y, right? So now I have 4 sets of 2x plus y. So I can sit there and say, hey, I've got 2x's here, 2 more here, 2 more here, and 2 more here, which gives me 8x, and then I've got 1y, 2y, 3y, and 4y, which is going to give me 4y. Okay? So what this is saying is this 4 sets of 2x plus y is equal to this 8x plus 4y, because, well, that's exactly what I have is 2 sets of it. With the distributive property, what they let us do is distribute that 4 into it, right? So if I have the original problem up there is this guy, right? And it lets me distribute that 4 in there. So 4 times 2x is 4 times 2, which is 8, and then we keep our x. And then 4 times y, which is 4y. So that gives me that same answer there. And for all those people that are telling me that I'm taking a constant 4 and multiplying it by 2x, which are not like terms, and I can't do that, that's not necessarily true. What's going to happen with that is you notice that when I combined it like terms up here in this addition problem, okay, when I combined it like terms there, I added the x's together and I added the y's together. Combining like terms only works when, or is only important when you're adding and subtracting letters or terms, right? So it doesn't count in multiplication. So, all right, this is going to be my next attempt. Let's see if I can delete this. And then, okay, now this is where the distributive property gets a little challenging. This is where the distributive, or where you're using your knowledge of greatest common factor and factors that you had before. So what happens and what makes the distributive property a little more challenging is sometimes they will ask you to go backwards. So you've got your numbers, they want to go back out into that format of a number on the outside and 2 terms on the inside, right? So to do that, what you have to do is think, what's my greatest common factor of 40 and 32? So hopefully you're figuring that out. I believe the greatest common factor of these guys is 8, right? So what I can do is rewrite this problem as 8 times 5 plus 8 times 4. This guy is equivalent to 32. This guy is equivalent to 40, right? So now I've got this common factor that I pulled out of it. So I can rewrite this problem as 8 on the outside and say, hey, I have 8 sets of 5 plus 4, right? And that ends up being equal to what we have over here. And for you sitting there doing it, and we can do it real quick. Obviously, this is 72. This is going to be 9 following order of operations, and 8. 8 times 9 is still 72, right? So they are equivalent. So this is where the challenge is. This is where the challenge comes in. It's actually going in and trying to pull out a factor that they have in common. And it gets even more challenging when you insert variables. So if you have something like this, 8 plus 8x, you can't add them together because they're not like terms, right? One's a constant and one has the variable x. But what you could do is say, hey, well, 8 is the same thing as 8 times 1. And I'm going to add that to 8x, which is 8 times x, right? And now they have this common factor in it. They both have 8. You can take that 8 on the outside of the parentheses and rewrite it as such. Okay, so you can have 8 sets of 1 plus x. And if you want, you can check your work by distributing that 8 back in there and say, hey, that's cool. All right, 8 times x is 8x, right? Because that's what 8x means, is 8 times x. Now, hopefully that you're doing okay with that guy. I can give you another example with some different numbers. On the review sheet that I sent home for your Friday test, they had the numbers 24, and I'll just put an x there, and 36, right? So if I have 24x and plus 36y, the actual problem on your homework or on your review sheet was find like the GCF of 24 and 36. So GCF, and hopefully you remember that the GCF of these two numbers is 12. Okay. If it's not ringing a bell, you can do the math yourself. You can pause the video right now and do the math yourself. But so we can rewrite this guy. If we know the GCF is 12, I can rewrite 24x as 12 times 2x, because 12 times 2x is 24x, and 12 times 3y, right? So if I'm going to multiply 12 times 3x and 12 times 3y, now I have this common factor of 12 that I can draw out, and I can bring in my 2x, and I can bring in my 3y. So how 24, oops, that's the worst for ever, 24 plus 36y is equivalent to 12 on the outside of the parentheses and 2x plus 3y inside. So that's 12 sets of 2x's and 3y's. Okay? So this is one way the distributive property gets a little more challenging when we're asking you to pull out factors. Okay? Now, one thing that I didn't put in the other video that I'd like for you to talk about is kind of another way the distributive property helps you with mental math. So this is, again, where the distributive property gets a little more challenging, so it can fit under distributive property 2, is if you have something like a math problem like 15 times 99. 15 times 99, all of you guys are rushing to your calculators to pull this out, to figure this out, or you would, but what I'm telling you is you can do this mentally, okay, using the distributive property. If you remember, 99 is equivalent to 100 minus 1, right? That's the same thing, 100 minus 1. And if I put a parenthesis here and 15 on the outside, a number next to the parenthesis means multiplication. So now I've got 15 times 100 minus 1, and everybody's going to agree that 100 minus 1 is 99, so it's exactly what I have up there. So now this math you can do in your head. You can distribute the 15 and get 1500, and you can do 15 times 1, which is 15, and put a subtraction sign in there, and realize that the product of this original problem up here is my guy down there. 15 times 99 is 1485. So all this math can be done in your head. I'll give us another example. Hopefully I haven't worked through this problem, but it even can be on something if you have 14 times 19, all right? You can treat 19 as 20 minus 1, okay? And 14's here. So you do 14 times 20 minus 1. 14 times 20 is 280, okay? And 14 times 20 is 280, and 14 times 1 is 14. So 280 minus 14 is 266, excuse me, right? So 14 times 19 is 266. You got to use the distributive property. You can do all that math in your head. Because I have some time, I'm going to give another example of this. My other example of this is if you say you had 14 times 28, right? 14 times 28 is the same thing as 30 minus 2. 30 minus 2 is 28, right? So I put my parentheses out here. Oh, this just got harder for me. 14 times 30 is, 14 times 3 is 30, 32 is 420, is it? 420. 14 times 2, if we remember, is 28. And so now if I do my subtraction, I know I'm looking at 39. I'll erase that guy. If I'm looking at my subtraction, we're looking at 392 as my answer, right? Hopefully that works out. 420, 20, yeah. So this is again a way that you can use the distributive property to solve more complex multiplication problems. Multiplication problems that, you know, historically you'd have pulled out the lattice way or something like that to solve it. And so, all right, thank you. Hopefully this works out for you.